Hey everybody, it is 2 hours UTC and it's time for Astronomy Daily Live. You can call me Cosmic, and hey, I hope everybody's doing well out there today. Everything's pretty well here. It's actually a little storm. I guess I wouldn't call it stormy, but clouds, thick clouds, and wind, and pretty unusual for this time of year in this particular place on the planet. But I'm sure we'll make it through just fine. Just fine. So, yeah, I hope everybody is doing well. I'm going to tweet the fact that I am live. Oh, I got to hit the right button. There we go. And I've got to get myself out of this mode, because if I keep my live stream going on my Linux machine, it will freeze my Linux machine. I have absolutely no explanation for that whatsoever, except it's a crazy world. So let me get myself set up here. I'm going to start the live stream on the smartphone. Come on now, you can do it. Thanks, Uncle Bill, for retweeting. Always appreciate that. Come on. Don't quite understand why I'm not getting it here. Now I do have, there we go. Now I do have coffee tonight. Coffee in the thick mug. You can see how thick that mug is. It's my favorite mug of all time. I don't even remember where I got it. I just got it. All right, very awesome. So yeah, I hope everybody's doing well out there in the universe. Miss Lady Catherine, hey there, Tom. Nice to see both of you back in the chat. Hope all is well. So yeah, this is just a fun, casual get together of friends. We gather in a circle, sort of like a virtual porch, right? We go and we pull up our favorite chair, grab our favorite beverage or other consumable, and you know, turn off the TV, forget the news. We just sit here and think all things astronomical for a while. And I was just I um, uh, back when I was a kid. I don't remember exactly when I got these. I wonder if I put a date. Hold on. Now there's no date on these, but I got this series of books. This is five books, 5 book set, and I don't even know if it's still available or not. Maybe it's updated, maybe it's completely out of date, but it's the Webb Society Deep Sky Observer's Handbook, and this one in particular is volume 3, called Open and Globular Clusters. Let's see, volume 1 is down on the ground over there because I was looking up binary stars the other day. So volume 1 is binary stars. Thousands and thousands of binary stars are listed. Hey there, Uncle Bill, painting the place yellow as usual. Hope all is well with you. So volume 2 is called Planetary and Gaseous Nebulae. Volume 3 is this one, as I said. Volume 4 is called Galaxies, and Volume 5 is called Clusters of Galaxies. And as the name implies, these are some handbooks to sort of help you, help the amateur observe various deep sky objects. Now, a deep sky object, that's sort of a strange strange term. I sort of prefer the term non-stellar object, which is also sort of a strange term because an open cluster of stars, uh, it's an object that's made of stars. So, is it a non-stellar object? Well, yeah, I don't know. Anyway, whatever you call it, it um, the the deep sky objects are usually characterized as things that aren't like single stars or uh, even binary stars. I don't think I would characterize a binary star as necessarily a deep sky object. But what we're talking about here is open clusters, globular clusters, galaxies, planetary nebulae, and gaseous nebulae. Those are sort of the deep sky objects, the non-stellar objects, NSOs, as they say. Oh, this coffee tastes good tonight. So yeah, I got this series of books um, back when I was a teenager of some sort. So that's got to be 30 plus years ago now, and had them ever since. As you can see by the condition, right? By the condition of these books I really didn't use very much. I use them as a reference for sure, when I wanted to look things up. Um, but what they do is they sort of give a really a really nice description of what to look for, how to look at these objects, how to observe them and actually take um, um, observing notes. So it's not just a matter of looking at them, but actually, you know, um, well, yeah, finding them, looking at them, moving on, but actually, taking some time to look at, brightness and shape, and whether, like in the case of a galaxy, whether it has what's called a stellar nucleus, which is a nucleus that looks like a star. If it Also in the case of like a galaxy, if it gradually brightens towards the center, or if all of a sudden, you know, it's very very bright. If you see any dust band, all that kind of stuff. And so yesterday we were looking at a globular cluster, NGC 2419, if I remember right. I think so. I think so. Um, and so yeah, that sort of got me thinking, oh, I'll pull out my Web Society handbook here and see what they have to say about globular clusters. Now, let me let me look at the publishing date of this book, just so we can put it into context a little bit. Hold on. So 1980 is when these books, um, this particular version of these books came out. I, as I said, I don't know if these exist anymore. I don't know if there have been updates. I'm not exactly sure. That's something to let's look. Let's look really really quick here. We can look together. As I said, this live stream is not necessarily about science communication or science um, education. What this channel is about is you and I going along on a and this might sound a little strange, but we're going along on a journey of passion. So, and of course, in this case, the passion is astronomy. There's other kinds of passions that are as exciting, but this one in particular is the passion of astronomy. So let's just see. I have absolutely no idea, and that's why I like to sort of take you guys along on these journeys of discovery. So Webb Society Deep Sky Observer's Handbook. Let's just see what's up with these guys. Do they are they still doing it? Looks like maybe they are. Webb Deep Sky / publications. Here they are, the Webb Deep Sky Society, an international society of amateur and professional astronomers specializing in the observation of double stars and deep sky objects, founded in 1967. So let's see, publications, deep sky observing guides and atlases. Okay, so they've expanded since I last looked into them. It's a long tradition producing high quality guides and handbooks. Let's see our current publications. Let's take a look here. They've definitely expanded their repertoire. Don't see these particular books anymore, though. Am I just not looking in the right place? I don't know. Handbooks and guides. Let's go back here and see. Ah, this mouse thing really gets away from me. Profusely illustrated, the Deep Sky Observer is the consolidated publication of what was formerly the Quarterly Journal of Deep Sky Observer. Details of our publications no longer in print. I wonder if, yeah, wow. And, okay, so our observation handbooks are no longer in print, but can be found secondhand. And look at this. These are ones that I don't have. I don't even know if I was aware of them. Probably because, see, you can see the dates here, okay? I would have gotten these in about 1983, 84, 85, something like that. Probably 83, 84. So by the time 1987 came along, oh, I was riding the rocket, right? So I didn't have any time for observing uh, uh, at all, as far as that goes. But it looks like they came out with 3 additional volumes: the Anonymous Galaxies, the Southern Sky, and Variable Stars. Well, very cool, very cool. So yeah, if you're so inclined, uh, go to your local used bookstores and yeah, see if you can come across these. I'll bet you might be able to. You know, one of the things now I travel very 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 rarely. I haven't traveled. Whew, man, I haven't traveled in so long. I don't remember the last time it was. Um, but when I do travel to a new place, um, besides picking up rocks on the ground, um, one of the things that I'll do is I will visit some used bookstores. I love used bookstores. So Yes, Tom, riding the rocket, the astronomy rocket. So when I was 6, I started building my rocket in quotes and hopped on. And in 1987, um, I moved to Tucson and became uh, um, um, an astronomy student at the University of Arizona, and that is when I lit the rocket. And I've been riding that rocket ever since. So yeah, yeah, and sometimes rockets go really, really fast, and you cannot hold on to everything. Things just fly out of your hands. And one of the things that definitely flew out of my hands were the Webb Society Deep Sky Observers handbooks. So, but I've held on to them, of course, because they're astronomical, and I'm not going to let any of that go just yet. And as I said, they're a great um, reference. But yeah, they are no longer in print. Man, that's let's see. How am I going to? Oh, I didn't share that. Did I not share my screen? I didn't share my screen. Wow. Let me, should I do that really quick? I thought I did. I thought I shared my screen. Maybe I hit stop sharing instead of hide. All right, there we go. There we go. Sorry about that. So, yeah, our observation handbooks are no longer in print, but can be found secondhand. Secondhand. So, yeah, take a look around. If you're so inclined, see if you can find them. It looks like the Webb Society, the Deep Sky Society itself, is still up and running. I never got involved with this group at all, but sounds like an interesting group. Sounds like they're active, annual meetings, and then just various links to various areas of interest. Very cool. All right, so now I'm going to stop sharing. Bad on me. Excuse me. Another sip of coffee. So let's look and see what the Webb Society says about globular clusters and observing globular clusters. Uh, so William Herschel, I guess, was the first person to sort of describe and recognize a a globular cluster as a rich collection of stars. Most I can think I can say with pretty good certainty that most or all um, globulars are pretty spherical, right? They're pretty round. You're never going to see any elongated ones, anything like that. And typically, there's between 50,000 and maybe 500,000 stars um, in these things. I sort of um, um, describe it as a swarm of bees, right? Just all buzzing around a common center. And the idea is, at least, that all of these stars were formed at the same time, about the same time that the galaxy was formed. So, these are pretty old stars. I think pretty massive stars. It, One of the interesting things though about that is that supposedly these stars are really old, but many blue stars have been observed in these clusters, and for a long time, it's like, what is going on? These things are supposed to be really old, And really, really old stars are usually cool and red. So it's like, what is going on? What's going on? So the theory is that stars within these clusters have actually merged. They've merged, and when they merge, the resulting single star has a higher mass, which increases its temperature, which changes its color from red to yellow or blue. So they're called blue stragglers, and yeah, they're. I need to remind myself about that theory a little bit more because you know one of the one of the problems that I have with that, right, is that as far as I know, these mergers have never been observed. And I'm now I'm really into the theory, right? I like the theory, I like the models, I like all of that, but I also like the observation. I like the entire scientific process, not just one aspect of it. So it's great. It's great to develop theories and build models and all of that. But bottom line is that, at least for me, is that if you can't observe it, if it's not been actually observed, then mm, it you've got a good guess, and there might be all kinds of indications. You might be able to infer, you might be able to extrapolate, you know all of that. But um, until you actually see two stars in a globular cluster merge, um, which I would think, wouldn't take very long, and maybe that's at least one of the excuses given for not being able to see these things, is that it takes, I don't know, hours or days or something, and all of a sudden, what you saw before as sort of a red star, or maybe um, two red stars, uh, are is now a blue star. So I don't know if that's ever been observed. I've never poked into it enough to really, really, really know. But it's an interesting idea, and yeah, I wouldn't be surprised if those kinds of things happen, um, because we're talking about a very, very, very rich area of space where there's a lot of stars packed into a relatively small amount of space. So it looks like Pamela Gay, Star Strider, is on her Twitch stream painting planets and talking science. So make sure to check her out if you haven't. Um, Feel free to go over there, even now. Now, Uncle Bill, I know, has like 20 screens up, right? He's like, in Back to the Future, when Marty McFly's kid comes home, and he turns on all these different channels, right? That's sort of how I envision um, um, Uncle Bill um, doing his thing, ninja style. Just all these screens and stuff. So Uncle Bill has the ability to watch, you know, 50 to 100 channels at the same time, and not all of us can, but I'm just letting you know that oh, okay, it's story time. Okay, I'm just looking at my notification here, and yeah, I guess she hasn't changed the title yet. So she is still reading off on a comet. Very, very, very cool. Very cool. I It's one of the things that I wanted to do on this channel was read some books out loud, and I did a couple of practice runs. I was actually going to read outside, um, which was very, very nice, and yeah, it's a lot harder. It's a lot harder than what it looks like. So yeah, I still want to do that, but I guess you have to worry a little bit about copyright stuff and all that. I was just going to go for it. Um, but um, so yeah, um, I actually did one um, reading, and uh, it it yeah, it's just really really hard. It's really really hard. It's a lot harder than what you might think. So cheers to Pamela Gay for uh, reading that out out loud. So cool, 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 cool. All right, so back to globular clusters. I don't remember what I was saying about globs. Oh yeah, yeah, the um, blue stragglers. Um, so yeah, that's still, to me at least, that's sort of a mystery as to why we're seeing supposedly all these stars that are the same age. um, I think more or less the same mass. Not exactly sure. Globulars are um, uh, kind of mysterious. We really don't know what's going on there. Why are they there at all? They make up this portion of the galaxy that is commonly called the halo, because if you plot the positions of the globs relative to like the center of our galaxy, or in fact any galaxy, what you'll see is that they form sort of a spherical ring ring, like a spherical sphere um, around the centers of the galaxies. Tend to be within 10 or 20 or 30 or 40,000 light years uh, out. Now, there are exceptions, of course. NGC 2419 is one of those exceptions. What, it's like 250,000 light years out. But, something else happened there, right? And they've got this theory that globular cluster was actually associated with one of the Milky Way's um, um, companion galaxies. And when that galaxy started interacting with ours, this globular was sort of flung out into this weird orbit. And so, yeah, who knows? Who knows? I think there's still a lot, and don't quote me on this, but I think that there's still quite a bit of mystery about why globular clusters exist at all, and you know, uh, um, you know, how they evolve, why they look the way they look, why they have certain populations of stars, that kind of stuff, right? Um, let's see. So I'm back to the Web Society handbook here. So yeah, this is sort of a historical thing. Galactic globular clusters. Um, with globular clusters, we are concerned with objects that are of high intrinsic luminosity, great age, and in contrast to um, Open clusters did not show a space distribution that is largely concentrated to the galactic plane, right? So open clusters tend to lie in sort of the disk, of spiral galaxies, where the globulars tend to, as I said, be centered around, the center of the galaxy. So that's pretty cool. Let's see. The study of globular clusters takes us back to the early evolutionary stages of the galaxy. Um, Information derived from studies of globulars is of importance in that knowledge of the early chemical composition of the galaxy can be obtained. This chapter will be concerned with the various properties of globular clusters. So classification, let's see. Um, so there's Shapley's classifications, which goes from class 1, which is the most highly concentrated. So that means, the stars are most tightly packed in there, to class 12, which is the lowest concentration. Astronomy, classification of objects is nowadays not always a structure-related procedure. We have only to think of Seyfert galaxies in that context. Um, it's been known for some time that those stars in the galaxies whose spectra show a high metal content are young objects. Older objects, among which are included globular clusters, are all known to be metal poor. Metal poor. So this being a product of their formation in the early epochs of galaxy evolution. And Ichi knows. Let's see. So yeah, okay. Um, so they've also classified them in terms of metal abundance, right? There's a class A, class B, and a class C. Uh, Medium metal abundance, low metal abundance, and very low. So relation of globular clusters to the galaxy. If one, okay, yeah, this is just what I said. If you look at a plot of globulars in relation to the center of the galaxy, they seem to cluster around the center. Diagram of concentration center is well seen, so you can sort of see in this chart, right? So along the x-axis there is the galactic longitude, right? So right in the center is 0 degrees longitude, and then along this side is the galactic latitude. So you can see that the positions, oh, ouch, that the positions of the globular clusters, of the known globular clusters, do tend to be centered around the center of the galaxy, where 0 and 0 sort of cross there in the middle. There are exceptions, of course. Have to have exceptions, because if there weren't exceptions, there wouldn't be any science. Let's see. Structure of the classical globular clusters like M13 and Omega Centauri, familiar, right? So the majority of the Messier objects that are globulars um, are of concentration 5, concentration 5. So pretty tight, right? I mean, remember it goes from 1 to 12, where 1 is the most concentrated and 12 is the least. So 5 is, leaning towards the most concentrated. Um, M55 is, however, class 11. Class 11. I would also put what is it? M71. Is that the one in Sagida? Is that yeah? I think that one. There's some controversy, maybe still, whether that's a globular cluster or an open cluster, a very very loose globular or a very very rich open. So not quite sure. Man, I got an itchy nose. So at least at the time of this publication, there were about 130 known globulars in the galaxy, in the Milky Way galaxy. Let's see, let's keep going here. Um, an actual diameter of 61 parsecs. Small z, such as NGC 6838, which has um, an intrinsic diameter of only 6 parsecs. So they go from 61 parsecs, and a parsec is 3.26 light years. So 61 parsecs is well over 100 light years across, down to 6 parsecs, which is about 10 light years across. The integrated photographic magnitudes of Palomar clusters are on the order of 15th magnitude. It's a color magnitude diagram, 15. So it's showing the different stars in M15 there. This is a color magnitude diagram. We've talked about those a couple of times before. Definitely need to talk about them a little bit more. There's a lot of information that you can glean from these very 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 simple plots that are just looking at the colors and the brightnesses of stars, and just from that information, if you plot it this way, right? If you plot it like this, you can glean all kinds of information about um, stellar evolution, the populations that are um, well, the populations of stars that you're looking at. Um, very very cool stuff. Very very cool. So color magnitude diagram. Um, Horizontal branch, giant branch. Okay. Figure 8 shows the color magnitude diagram for the cluster M15. So that's the color magnitude diagram I was just showing, and the difference between this and the diagram shown for the Pleiades on page 13 is immediately apparent. Let's look at the two color magnitude diagrams for M13. I'm sorry, M15 and the Pleiades, which is M45. So hold on, I'm going to show you these plots again. So you can see that there's quite a difference between those two plots. The globular cluster plot most certainly has a more diverse population, right? Sort of all over the place. let's see, evolution of globular cluster stars. At first sight, the color magnitude diagram for M15 on page 30 appears rather anomalous. A turnoff point is visible, and yet there are still luminous stars to the upper left of the turnoff. In order to explain this, we shall now define the process through which stars in a globular cluster pass um, in order to register on such a color magnitude diagram as shown in figure 8. All right, we're not going to get into that. Well, why not? The greater part of a star's lifetime is spent on the main sequence. Upon leaving the main sequence, the star will spend about 10 to the ninth years, that's a billion years, on the subgiant branch, which lies below the giant branch. During this period, hydrogen undergoes nuclear reactions which transform it into helium. So eventually, a star will reach a period in its evolution where it'll appear at the uppermost point of the giant branch. So that's up here, right? This is the GB giant branch. So way up here. So it starts down here on the main sequence. I know that's hard to see, and then it creeps up this way until it reaches this point, and then it drops back down like that. At least that's the theory, right? This is what is observed, and yeah, well, colors are observed. Colors and magnitudes are observed with a lot of stars, and you get these patterns, right? You get these patterns. We haven't been around long enough to watch a star actually, move at least too much along these lines. But the idea is that they do actually move along those lines. So at this point, helium in the core starts fusing, and that's called the helium flash. And at this point, the star will switch position on the color magnitude diagram and appear on the horizontal branch. That's over here. Right, so it'll do this jump. Sorry about that. It'll do this jump, and it'll go on to the horizontal branch, so-called horizontal branch. Its position as part of the diagram will depend upon the amount of mass it has, right? So yeah, this goes on and on and on here. Let's. They talk about globular clusters in external galaxies, which we can see for sure. So now it goes on a little bit, but then it gets into the observation of globular clusters. So let's see. Intrinsic factors. So there are these concentration classes, right? That goes from class 1 to class 12. Integrated magnitudes. Brightest star magnitudes. So you can measure the magnitude of the entire cluster to sort of get an idea there, and then you can look at individual stars and look at the magnitudes of those as well. Let's see, non-intrinsic factors, galactic obscuration, large numbers of dark nebulae are to be found plotted on these, however, are only the most obvious samples. I'm not exactly sure what they're talking about, galactic obscuration, except that maybe they're talking about stuff in between us and the globs, sort of obscuring them. Yeah. Cluster distances. So yeah, it looks like the closest globular cluster to us is like 2.2 thousand parsecs away. So that's about what, 10,000 light years or so. That's the closest one to us. That's M22. I think M22 is down in Sagittarius, if I remember right. And then yeah, the furthest ones out, we already know are 250,000 light years away. So for the selected clusters, oh, they actually point out NGC 2419 here. It has its own special. Can you see that? NGC 2419 and the Palomar clusters. It's not only clusters situated toward the galactic center, which can show little or no resolution. Others at higher galactic latitudes can be just as difficult to resolve, often even more so. So there, at least back in 1980, they said that NGC 2419 was 61,000 parsecs away. So, and the information that we've got now places it even further away. Distribution of brighter stars in fully resolvable clusters will often show structures that departs from the total images as depicted in photographs. Yeah, if you look at globular clusters through a telescope with your own eyeball, and are able to see, all the way down to the centers of these things, there's some structure there for sure. It isn't just a uniform distribution of stars. Not only do they get more and more dense as they get towards the center, but yeah, there's some structures there as well. So yeah, take a look at that. Let's see. Okay, so that's about it. That's what Webb Society Deep Sky Observer's Handbook has to say about globular clusters. Very, very cool. I think, in terms of observing, of eyeball observing, my favorite will always be galaxies, for sure. But I think next on the list are definitely the globs. Definitely the globs, because they're sort of like little galaxies, but you can usually resolve, at least the outer stars really, really well. Cheers. All right, well, cool. I think that I am going to exit these waters for today. Cut it a little short. Um, no particular reason. Just yeah. Let's have a nice, relaxing rest of the day and enjoy all this astro talk. And it's it's so great to see other podcasters and other um, live streamers doing the astronomy thing. I think it's very, very awesome. Um, I know that that this topic is pretty popular. I think a lot of people um, um, get a lot um, from these kinds of things, and yeah, I'm in a really, really great community of some really, really, really smart people who really know their stuff. So it's great to, sort of be a part of that. And I'm still a newcomer as far as all this goes. Others have been doing this for years and years and years and are really, really good at it and know their stuff really, really well. I am just learning the ropes, learning the ropes. So having said that, I think I'm going to get out of here for today. Hope everybody has a great evening and a great day wherever you are. And if you've just stumbled upon this live stream, make sure to subscribe. You can hit the thumbs up or the thumbs down, whichever you prefer. Um, Make some comments. Spread this around. I want to. I'm still looking for my core group. I found a few of you. But there are quite a few more out there that I still need to find, so we can gather around this circle of friends. If you want, every single day, right? You can come in here every single day at the same time, and we'll talk astronomy for a while, just a casual, fun while. Um, if you don't want to come every day, come every other day, every week, every month, every year. Come on in. You are welcome. You can be new, completely new to this. Um, you can be an amateur. You can be a pro. I want you to come on in. Come on in. There's Patrick Manny with his duck and his cloud, which is just absolutely baffling me. So Patrick Manny, um, uh, I uh, I enjoy the symbolism, but I don't understand it at all. Now, the matter inside of this skull, um, I characterize oftentimes as like neutron star matter, right? It is extremely dense, extremely dense. So the simplest things in the world, like like a duck and like a little cloud, right, is completely baffling me. Well, Miss Lady Catherine, that's exactly what popped into my head, but I don't get that either. I don't get that either. So yeah, I think I'm just being really, really dense, um, and you know, um, uh, oh, okay. All right. So it's your trademark. Okay. Very cool. I fully endorse it. I fully endorse it. I think it's great. I think it's great. So yeah. Um uh I you know it it's very symbolic, and if part of the intention is to bring a smile to people's faces, it does. When I first saw that, it's like, what the hell is he doing? What the hell is he doing? So yeah, very cool. I'm so glad you're here, and jet powered ducks. Yeah. there's a uh, there's a little town in southwestern New Mexico called Deming, and I forget exactly when it is, but they have duck races, and when you drive into um, Deming, there's a big, like a billboard sign, right, and it says something like, "Welcome to Deming. Um, um, Friendly people, good food, and fast ducks." so so yeah, and yes, work is a four-letter word, which, and I try to avoid all four-letter word things for sure. Work is one of them. Now, one of the four-letter words that I don't avoid is easy, Easy is probably one of my favorite words of all time. Now, my favorite word, my favorite English word. Can you guess what it is? My favorite English word, uh, and I adopted this years and years and years ago, probably back when it was actually probably one of the first words I ever said, right? It's probably one of the first words that I ever said. And that is my favorite word of all time, no. That is my favorite word, no. I like that word a lot. All right. Having said that, I'm going to get out of here now. I have stalled long enough. Yes, the mothership is calling, beckoning. The coffee is nearly empty and cold. So I'm going to get out of here for now. And yeah, you know, uh, Patrick Manny, that's actually one of my probably top 10 words as well is why. That was probably one of my early words too. So yeah. All right. I am definitely going to exit this planet. Make sure to thumbs up, thumbs down, subscribe if you haven't. You can hit that little bell and get notifications in terms of when I go live. But I do go live every single day at 2 hours UTC every single day. So for me, I'm on Mountain Standard Time. I'm in southeastern Arizona, United States, and that puts me 7 hours behind UTC. So it's actually what 2:57 UTC on May 2nd, 2018. But for me, it's 7:57 p.m. on May 1st. So happy May again. Yeah, we need to talk about May events. Maybe I'll try to remember to start doing that tomorrow. All right, you great people. Take care, and I will see you on the spin tomorrow, 23 hours and 3 minutes from now. All right. Take care, everybody. Bye.